What we're looking at today is yesterday was a lot of new notation. And I just want to make sure that we're feeling okay with this new notation because AP is going to ask us questions with fewer words now and more symbols. So, rude. So let's take a peek at this 2-3. We're on page 9. Look at what they're asking. It says how to estimate the derivative at a given point. Given a table. So again, this is new to us today. What does that mean? H prime of 6. That's how I'd say it. What does it mean? The slope of H at exactly. Now, look at this table. Did I give you an x to 6? Sure didn't. Anyone have any idea what points you might want to use if we're looking for 1x to 6? Soph?
Can we do 7 minus 5?
She's like, if 6 is going to be here, we should probably look right around it, right? That's what they want you to do. Go to the closest points on either side because the average slope between those two will hopefully be the closest to the point. Dealio? So what would you write if this was a free response question? 70 minus 45 over... You got it. Are we done there? Yeah. You can be, though, right? What if they asked for units? They didn't, but what if they did? Exactly. We just did change in Y over change in X. We just did the 70 over the 7, so we're going to just say meters per second. That'd be a perfect answer. If this was multiple choice, what would that top simplify to be? Close. 25 over 2? It's cool. If you just wrote this for a free response, how many points are you getting out of 2? You're only going to get 1 point. Okay? I agree. You guys, I gave you a bad question here. I need this to be at -2. Stupid me. Here's why I'm changing it. They will always ask you to estimate the slope from a table at that point right in between given points. They're never going to give it closer to one or the other. So my bad. Go ahead and change that. How are we finding the slope of that guy? Over? Perfect. What if my man Colin said 1 minus 9 over -1 plus 3? Perfect. Agreed. Doesn't matter because they both are going to simplify to -4. -8 over 2 is still -4. It makes no difference which one you do. Go ahead and grab your calci. You're going to love this. This is just reminding you to find the average rate of change. Go use points that are close. Okay, let's use our calci to go find G prime of 1.2. Anyone remember what we're using in our calculator for that? How do I find that derivative? Math 8 is how we're going to do this, y'all. Math 8, you're going to say Math 8, and then go type that dx. So we're always going to use the variable x every single time. I wish that I just put it in there for you. We're going to go type in that equation. Be careful. It needs to be the x cosine of x. A lot of people forgot that x in the first one. We must be in radians. When do I want that slope? When x is 1.2. Anyone get -0.756? What if, this is kind of a silly question because you obviously have a calculator for this, but how could I figure this out if Math 8 wasn't an option for me? If Math 8 wasn't an option and I want to go find the slope at 1.2, what could be two values on either side I could use? You're saying 1.3 and 1.1? Those are two x values on either side. How would I go get the y value? Yeah, let's go find when x is 1.3. So again, this is pretty silly that I'm having you do this, but I think it is good practice that we could say, all right, this is kind of what you were saying, Nelson. Yeah. F of g of 1.3. I'm going to go plug in 1.3, and that's going to get me my y value, right? So I would just do 1.3 cosine of 1.3, and I got 0.348. And then if I plug in 1.1 cosine 1.1, 0.499, what would I do with that info? If I'm trying to find the slope now. Change the y over change the x. So I'm going to just do 0.499 minus 0.348 over 1.1 minus 1.3. I'm going to go use the full decimals from my calculator. I'm going to use that up. Did I mess up?
No, you didn't.
Divided by 1.1 minus 1.3. And I got an answer of negative 0.756. Was that pretty close to the derivative my calculator gave me? Oh, snap. I feel good. What if AP said, okay, here's this function. I'm going to just graph. You guys don't have to do this. Don't graph any of this stuff. Here's this function of x cosine of x. And I want to know what the equation of the tangent line is. This is what we talked about yesterday. At 1.2, I want to know the equation of that tangent line. So you guys, don't we already have the slope of that tangent line? Mm-hmm. How would I go get the y coordinate of that tangent line? I love it. I just heard. Let's go find g of 1.2. Let's go find that y value. If I plug in 1.2 to my function, again, I'm just going to go to my home screen. 1.2 cosine of 1.2. Anyone get 0.435?
Yeah.
Okay. So what would be the point slope form of that? I'm going to remind you off to the side. Point slope form was y minus y1 equals m x minus x1. What would be, again, this is all kind of new lingo, so don't be mad at yourself. You're like, I don't know how to do this. Let's think. Here's a point. Here's a slope. What are we going to do? Y minus, 0.435 equals my slope at that point, which was amazing, times x minus, okay. Now let me show you something pretty magical. If I go to my y equals screen and I go type that in as negative 0.756 x minus 1.2, you don't have to type this in. I'm going to add my 0.435 over 0.435. Do you agree I just put this as y equals in here?
Yeah.
Just got my y by itself. Look at this. Okay, and my tangent right at 1.1. Let me prove you. Whoa. Thank you. Trace 1.2. Thank you, Greer. I don't know why that red dot is there, but boom. Or is the red dot my 1.2? Let's get that stuff away. Let's just go trace 1.2. Okay, all likes to move. I think the red dot's the point of tangency. Isn't that cool? Mm-hmm. You guys whoosh, drew the tangent line. Let's see if I can even zoom that in for you. Zoom in. This is actually the word. There we go. Look what we did. We wrote the equation of the tangent line through that point. We did it. Use your calci. Oh, the reason I gave you this problem is because this is new notation. What is this? Anyone remember how we say this? dy dx. What the heck is this thing? You're going to use this in college math a lot. I like how you said a separator. It kind of is. It's called an evaluation bar, and it's just saying go find the derivative when x is negative a half.
-2.
This is the same thing as saying what's dy. This is the same as saying what is f prime and -1. Guys, these are the exact same. I'm just letting you see some new symbols today, okay? Greer, you said it's -2. How'd you do that?
I did d over dx.
Yeah, so you did math 8, right?
Yeah.
We're going to go to that home screen, math 8.
Then I plugged in x squared minus pi.
Yeah.
And then x equals -1.
When x was -1, that one comes out so nice. You guys, do we get f prime of -1 is -2?
Yes.
Okay, I want the equation of that tangent line. We can do it. Let's go find f of -1. How am I going to do that? Yeah, what's -1 squared? 1 minus pi,
2.14.
right? 1 minus 3.14159 would be -2.14159. And again, you could use your calculator for that. No, wouldn't it be positive because a negative squared? Whoops. You're fine, Soph. -1 squared would get me that 1. So you guys, what's the equation of this tangent line? Boom. AP is going to give you a point for that, Sammy. Okay? Now let me just show you. Let's go see if it actually looks like a tangent line. If I graph my function, and my function here was x squared minus pi, and then I say my tangent line is -2, x plus 1, minus 2.14159. Does that look tangent when x is negative 1?
Yeah.
We are perfect. Guys, this one has a lot of words, but I think that these words are important to see. It's just saying if f of b is greater than f of a. Anyone, how can we interpret that on this graph?
F of B is higher.
Exactly. It's higher on the graph than this y value over here. Agreed. And then they're saying between a and b, they're saying we are bounded between a and b. Those are my bounds. Cool. And it says the derivative exists. We don't know what that means yet, and that's okay. Here we go. How many values of c between a and b? You guys see, they're just saying how many x values. Don't let that confuse you. When I was in high school, that would confuse me. They're just asking for how many x values between a and b. And then we got a lot of symbols here. Oh my Lanta. Let's talk about what these mean. This right here is the formal definition of that derivative. This one right here, you could just that's just f prime. That's just f prime. That's going to get you your slope. The one on the right is just the average rate of change. That's back to pre-algebra. Average rate of change over an interval. Change in y over change in x. Totally, buddy. So they're asking when does the slope of the tangent line, maybe that's how we might write this too, slope of tangent line. When does that equal the average slope? That's really what they're asking. When does the slope of the tangent line equal the average slope? Well, you guys, the average slope from A to B, how we'd show that is you just connect from A to B. Bam, that's my average slope. Would you say the average slope is positive or negative? Positive, okay. It's asking how many times, how many x values, how many times on that x-axis does the slope of the tangent line equal my average slope? Let's think about this. Right here, would you say the slope of the tangent line here matches that slope?
No.
No, how about here?
No.
How about here?
Yeah.
Wouldn't you agree those look pretty parallel?
Yeah.
How about here?
No.
No.
Here?
Yes.
Yeah, here.
No.
Here.
No.
Here?
Yes.
Here.
No.
Here?
Yes.
Yeah, how many?
4.
Yeah.
Would we have to prove that mathematically?
Not at all. Not at all. She said, would we have to prove that mathematically? Nope, we're just going on looks. If I were you, this is how I would show that on my page, just for your notes for future. I'd say that looks parallel. That looks parallel. That looks parallel. That looks parallel. And I might go like this, like boom, point of tangency, 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 tangency. 4 different x values have that same slope. Okay, let's grab our calculators. Let's talk about what we're going to do. It says, hey, we've got this function f. Where does the tangent line have the biggest slope? Let's go look at this graph, shall we? Let's go take a peek at this graph. So let's go plug this in into your y equals. So we got x to the 4th plus 1/2 x to the 3rd minus 5x to the 2nd plus the tangent of x over 2. And then maybe do yourself a zoom 6 window. This is a lot of cray. You guys, it's asking for what x values does the tangent line have the biggest slope? If I were you, I would do trace -2, enter. Right? Didn't they ask at -2? We're going to do a little guess and check here, people.
Oh, yeah, we can.
Can you see where x is -2 on your graph? I can't on mine.
My graph does not look like that.
I can. Did you get B?
Yeah, I got B.
What about as x is 1?
Negative.
As x is 1, that's a negative slope. So the only one that's positive?
B.
Feel okay with that, you guys? Great. Last one. Last one. Go find, again, you could have done this yesterday, but we're just seeing this notation for the first time. When they say what's f prime at 2 and you have your calculator, what are you going to do? You're going to math 8 it. Exactly. Math 8. Go find me f prime at 2. Second quit to get out of your graph. Math 8 e to the negative x plus the cosine of x minus 1. Ooh, 1x is 2.
I got none of those.
That was my thought at first too, Graham. but they're rounding. It does round to one of
Okay,
these.
Wait, so you close when you have the
What?
cosine. This
I got
cosine of x.
syntax
You gotta
error.
finish
You
the
gotta
two.
finish, that's what I was about to say.
Yep.
Wait,
Huh? Oh wait, do you have to put the X in parentheses?
Yes.
Yes.